Okay, so I want to show you a couple of things that you can do on the calculator. I may have shown you these before. I may not have. Some of you may already know how to do this. So if you know how to do it, that's great. Share with your friends and neighbors. Make sure they know how to do it as well. So what I'm going to do is talk about the problems whenever they give you a quadratic and they ask you questions about, can it have an area of 700 and that kind of thing. Um, so I'm going to need a page. So I'm going to add a page here. I need a graphs page. And when I get to this graphs page, you'll put in whatever quadratic they give you. Or if you had to write your own, I'm going to do that. I'm going to say that we had to write one that had a perimeter of 120, which I think was your homework question. So if we had that problem, we would end up with an equation that was, can't use L, so you have to use X. So we'd multiply the length and then times, we had, what was it, 60 minus the length. Oops, I used L. I said we can't, so I need to use X. You have to use X. So type that in your calculator. If you press enter right now, what is that saying? Oh, I know what when they have a parentheses like that, I don't know why, but they want us to be sure when we put times. So you have to put times in there. You press enter right now. What are we seeing? So this is a lot of times what frustrates students because they put it in there. They expect to see a parabola and we get this looks like I don't even know what. You have to remember that this piece of graph paper right here is not fit to see that quadratic that we just graphed because we already know that it's going to have a domain of between 0 and 60. So if it has a domain of 0 to 60 and all we can see is some 0 to 10, then we can't see the domain that we need to see. So you have to fix that. Now there's a couple of things you can do. You can, I don't mean to drag the label. You can, I think, grab the thing and pull it around. Okay, but still you're not going to be able to get very much. And if you grab the paper, then you lose your origin. And so we don't want to do that. So what you want to be able to do is go to menu and change the window. Okay, so let's see what you can do. You can fix it yourself, which is what I would prefer you do, but you can also go down here to zoom fit. And the calculator, see, does its best job. It fitted on its y-axis, but it didn't fit this number right here. So now we can see that it does look like it's a parabola a little bit more, but it changed the y-axis to go all the way up to 796, but it didn't change this to show my whole domain. So that's why it's better to fit your window yourself. So we're just going to go to window settings. Now we already know that our domain is 0 to 60. So I'm just going to be sure that my max number right here is, let's make it a little bit bigger than 60. And just because I want to be able to see the y-axis, I'm going to make this be -10. I know I'm not going to have any numbers out at -10, but I want to see it. X scale right here is how often do you want, where do you want the little marks? The calculator is going to automatically do that. I don't think I need to go down to -300, but that's fine to leave it there. I think I remember the maximum value being something like they ask us a question about, can you have a area of 1,000? So that's why I'm going to put 1,000. Maybe let's go over 1,100. Make sure that we can see everything. Again, I'm going to let it automatically scale the y-axis. So I'm going to press OK. You see now we can see it. If you weren't sure about what numbers, a trick you can do is to go to menu and look at your table. And if you look at your table, you'll see real quick that we need to have, big numbers It goes up to 800, goes up to 900, look like, and then, or, it started getting, and then they started going back down to getting smaller. Now, here's out at negative 66 is where we're down in negative numbers. So that would give you a good idea of where to help you figure out what the domain is. Where did my parabola go negative? Somewhere right there around 60. So that's a really quick, easy thing. And of course, just to get rid of that, you press menu and you go to table and remove the table. Okay, so now that we're here, what do we do? Well, there's a couple of things you can do. You can find the x-intercepts. You can have the calculator find the x-intercepts. You can do Control-G, and you can type in that 700. And it asks you, can we have an area of 700? And we can see right there that we can. We can find those intercepts. So I'm going to do all of that. I'm now going to find the intersection. What size would my rectangle be? If I want to find, what size would the rectangle need to be in order to if I have an area of 700? So let's do that. Let's go to menu. We're going to go to, what are we going to do? Analyze the graph. And if we analyze the graph, we're going to find the intersection because we want to find out where these two right here are touching. So you just have to get this little line on one side and then move it over and get it on the other side. And there it found the intersection for you, 15.9. So the length of my rectangle has to be 15.9. Then, of course, you would have to subtract that from 60 to find out what the width was. Or you can come over here and find it. Let's do the intersection again. Menu, analyze graph, intersection, get on one side of it. Oops. Press enter, get on the other side, press enter, and then we see the other section. The other intersection is 44.1. So a length of 15.9 and the width of 44.1, or a length of 44.1 and the width of 15.9. That's when our rectangle would have an area. If we wanted to find this maximum value up here, you go back to menu, you analyze the graph again, and since we know it's a maximum, we're going to press that number. We're going to come back over here. They want to know the maximum of which graphs. We want to do the maximum. Be sure you tell it this graph. So I clicked on it, and now I'm going to tell it to look between there and there because it'll give me a maximum anywhere, but I wanted the actual maximum. 3,900. So if it's a length of 30 and a width of 30, the area is going to be 900. That's the maximum. You can do the same thing down here for the zeros. You can go to menu, go to analyze graph, and tell it you want the zeros. Since you have a couple, it also wants to know the zeros of which graph. So the zeros of this graph. So we want to tell it to look between there and there. It finds a 0 at 60. Over here, we want to do the same thing. And I have to tell it again. Menu, analyze graph, find a 0 again for this graph. Click over here, and it tells you, there it is right there. It's telling you that it's 0, 0. Okay, so there's a couple of things you can do. Find the intersection, find the maximum, find the zeros. Your calculator will do all that for you. Your calculator will also find any x value. If I wanted to know what the area was when the length is, I don't know, anything, you can press trace, and we want to trace the graph. So you click on this right here, and I think you have to use the left or right arrow key. Use the left or right arrow key, and that's telling you down here that when the length is 26.5, the area is 888. If you want to know an exact value, let's say you wanted to know 22.5. Well, let's say you want to do 22.4 because it's skipping 22.4. So if you wanted to know 22.4, you just simply go over here and type it in, 22.4. And when you press enter, it'll show you the area is 842. So again, that was trace. You can trace it. Don't forget, you can also go look at the table. Okay, so that's my time for the video. Watch it again if I went too fast, but that's how you can use your graphing calculator to help you out with those values. Good luck.